Okay, hello everybody. My name is Enrico Natalizio. I'm the chief researcher of the Autonomous Robotic Research Center in TII, in the Technology Innovation Institute. So today I'm here because we started working in my research team with the General Civil Aviation Authority on supporting them for defining air corridors. And of course, the first step in order to understand what to do and how to do it is to study what exists in the literature. We found out several insights that are probably interesting to discuss, and so I want to share our dive into advanced aerial mobility. So first of all, why do we need advanced aerial mobility? I think is in front of everyone's eyes that we need to remove as many cars and motorbikes from the road as possible in order to pollute less, being less congested, have more effective trip time and in terms of time, but also in terms of money that we spend on the roads every time. So the technology for flying cars is something that is finally ready. This was a promise since probably the 40s or the 50s that the new century will bring flying cars, actually even before the new century, even before the year 2000. And finally, the technology is ready. There are several companies even operating in this country that are able to bring passengers and goods flying over the head of people inside the city. What is missing is that we need, first of all, to have a strong regulation in terms of safety, security, and sustainability, and we need, at the same time, to develop the technical part that is needed along with this regulation. So just to give you some context to understand what we have done in my research team, just as for the aircraft that you see on the left, there is defined, we have protocols defined for avoiding mid-air collision. This is the near mid-air collision protocol that defines horizontal and vertical distances needed to separate different corridors through which the aircraft will move. In the same way, we need to do the same for other kind of aircraft that might be manned or unmanned, but they will be at much lower altitude and they will share the airspace on top of our heads. So on the picture that you see on the right is just to give you an idea of what is important to consider. So the inner circle that you see is the actual diameter of the aircraft that we are considering. That might be a small one for delivering goods to a cargo bus that transports people. The area that you see around is the error that might be done, might be committed once we use instrumental tools to measure the position, the velocity, the acceleration, and so on. So we have to consider a bubble around the initial diameter of the vehicles. And then on top of that, there is another circle that represents general uncertainty that we can have and that we want to keep in order to be completely separated. So this is just to give you a small example because we will see more in detail some of the insight in this research. And what you see on the extreme right is actually having two vehicles that have different sizes. So one of the main issue, once we consider aircraft that fly into the city, is that the variability of aircraft is very high, is not as low as that we have with passenger aircraft of normal airlines. So what is that we have done? This was just to give you the context of what is that we aimed at, how to define air corridor for advanced aerial mobility. What we have done is a research that studied all the existing products in literature that consider somehow air mobility. This has been done using the PRISMA guidelines, which means the preferred items for systematic review and meta-analysis that basically state specifically a framework in which operate to pose some question and have research paper check if they answer these questions or not. So the PRISMA guidelines, asked as first step to propose some questions that will be checked in the research papers. And the 3 questions that we have posed are those that you see on RQ1, RQ2, RQ3. So what factors influence the corridor, the air corridor design? What factors influence the separation definition? And what methods are used for defining safe separation? So these were the 3 questions that we wanted to check what in the world has been produced in this sense. So what you see below, we have analyzed the papers from 2010 to 2024. The research was conducted up to June 24 was when we finished it. And you see that there is a variability in the number of papers that are growing. 2020 was the year of COVID, so we had found only 1 paper there. But you see that there is a growing interest in this subject. And 2024, we stopped at middle of the year. So probably that number 9 would have been much higher. In terms of countries in the world, there is also interest all over the planet. So USA is probably the one most represented, but then South Korea, Germany, Singapore, China, they are all countries that are pushing towards regulation and the definition of air corridors and advanced aerial mobility. So the PRISMA framework says you ask questions that have to have a context. So in our case, we did it for urban areas. So all the questions that you see over there are related to urban framework, to urban areas. So in urban areas is the context. It requires a mechanism that is for example, what factors, so the factors that we ask for is the mechanism that produces an outcome that is the design of the corridor. Okay, so all the questions have to follow this framework of context, intervention, mechanism, and outcome. So we did this research. We found, I cannot read the number from here, but we had around 2,000 papers, I think, of which 90 were duplicate, so they were removed. Then there is a phase of screening, and we reduced the number to 1949, I think. And then these we studied more in detail, a certain number that in the end shrunk down to 62 papers that are those that really brings a contribution in at least one of the questions that you see on the left. So the first result of this research was to define 3 phases. So what all the researchers around the world in the end agree on is that in order to define air corridor, the first thing is to define, of course, the vertiport design. So here on the right, you have an example that I took from the website of LOD and Skiport that proposed one for Abu Dhabi. And you see that there are different kind of aircrafts in the rendering. But basically, there are 4 main factors that are needed to be investigated once we want to deploy a vertiport. The first is the demand, of course, which point we want to connect. Well, where is A, where is B? And of course, this requires investigation on the most demanded area for this kind of transportation, as well as the current connection that these A and B have, because we want to make a comparison in terms of effectiveness, time, cost, and so on, of the current solution that might be simply going by car, or it might be multimodal. We go by car and then we take the metro, or we bike until a taxi station and so on. The second factor for the vertiport design, the feasibility. So we have to find spaces where locations are sufficiently available in order to allow all the operation that will be done in the vertiport. And we need that this area is free of obstacle, at least for the landing and the takeoff that are the most sensitive operation in a vertiport. Then we need to respect the current regulation. This means, of course, whatever is in place. And according to the research that we have done, the UAE has one of the most advanced regulation for the vertiport design and the advanced area mobility in general. We need to respect all the constrained environmental, regulatory, and noise and other aspects that are included in the regulation. And then the last thing is the viability. Is really needed to fly from A to B, or the current, as I said, in the demand, or the current transportation modes actually don't require to build the vertiport exactly in this point, because going by car or going in another way is pretty easy and viable in terms of cost. Second phase in defining the corridor is actually the real corridor formulation. Now that we know which are the endpoints, so which are A and B, where are the vertiports, then we have to describe the corridor that goes from A to B. And of course, the first aspect is again the feasibility. The feasibility in this case is of the path to go from A to B, whereas before it was just the area around A, if it was good or not. So feasibility in this sense means I don't have to have obstacle. I don't want to fly through skyscrapers, or I want to avoid as much as possible crowded area and define no-flight zones for the path to be free from potential risks. In the feasibility, we also include the capabilities, in this case, of the aircraft to stay on the predefined path, because, of course, it has to be able to move within the path that has been established, within the corridor that has been established, and this, of course, depends on the aircraft capabilities. If it's manned, also by the human characteristics, and if it's unmanned, of course, is mainly only the aircraft. Of course, the next aspect to consider in the definition of the air corridor is the safety. Again, is this free of obstacle, or we risk to cross potential areas where there are airplane going up or down, or other kind of aircraft that do any movements around? And at the same time, what is the impact on the ground? In the sense, am I flying on a crowded area where I risk to fall on a house, kill people, or a mall, or something like that, or not? And then the last point is the sustainability. We want this corridor, first of all, to be sustainable in the environmental sense. So we want to produce as low noise as possible, but at the same time, we want to be fair among the different operators that might want to get into the market of aerial mobility, and we need to be able to offer the same capabilities, the same features to different operators in the area. Last phase is the operational management of the vertiport and the flight itself. So even for this, we need to understand the demand, because we have to dimension the vertiport and as well as the flights that will be done between A and B according to the demand that is requested, and at the same time, what is the capacity of the aircraft to bring these people back and forth, bring in to the balance between the two things, and have a demand capacity balancing that might even be dynamic in a certain sense, and can be established not for the whole path between A and B, but even for smaller segments, so that somehow the demand might be for a segment of A to B and not for the whole path from A to B. So now going to the definition factors for the separation, you see this is the taxonomy that we came from, with still the numbers that represent the paper that we have analyzed. But there are mainly three macro groups that are interesting when we have to really go into the definition factors for the separation. So these three are the vehicle characteristics, the total system error, and the environmental factors. So just having a quick look into these three groups. The first, the vehicle characteristics, we have to have vehicles that are manned or unmanned. They have to be able to detect and avoid potential obstacles. We will see in the next slide that there are several rules or model of rules that can be implemented for detect and avoid. But for sure, this is one of the characteristics that the vehicle must have. The second thing is the flight dynamics. The flight respects certain parameters related to velocity, to acceleration, to the relative velocity between different vehicles, and so on, or not. So this is an important parameter. Then we have the total system error. As I said, if you remember the first slide I showed to you to introduce the context, we have this area of uncertainty that we consider all the time when we are speaking of aircraft. This is true for the manned aircraft, even more for the unmanned aircraft. There is a level of uncertainty and error. This error might be introduced by the GPS system or the inertial navigation system of the device itself that says I'm in position X, Y, and instead I'm in position X first, Y first, so far from the position that the GPS actually is telling me. So this is something that must be considered within the total system error for the definition of the separation between corridors, as well as the flight technical error. In this case, this is the error that is done by the instruments that are on top of the manned or unmanned aircraft, and that gives somehow the potential distance, or it gives, you see over there, communication control and then pilotage and weather, because these are factors that actually are needed to be considered in the moment that I have, for example, two aircraft that are going one towards the other. Do I have to consider the communication among them so that at least they can somehow decide what to do, or this is not important? So this is part of the total system error that must be considered for defining a safe separation. And the last one is the environmental, because the aircraft can be simply subjected to wind, wake vortices from the previous aircraft that is moving in the same area. So in this sense, this is part of the vertiport operation that we said before, to be able to create a schedule that doesn't create vortices between different vehicles, especially in the takeoff or in the landing moment. So the methodology currently used, the figure is a little pixelated, but you have the methodologies that are usually used for the separation with the addition of something new. So at the moment, how the separation is defined. Of course, there are standards to follow, so vertical and horizontal distances, but there might be operations that require somehow the pilot to do something in order to avoid the potential collision. So the VFR and IFR are the two techniques that are used at the moment. That is a visual flight rule. So basically, if the two airplanes can see each other and can be visible all the time, this can be given to the pilot to avoid the other airplane, according, of course, to certain protocols. In case this is not possible, and so you see that VFR is all the way down where the two airplanes can see each other, but if you go over the cloud, you see that actually they use the IFR. So in this case, it's the instrumental flight rule that is considered, and is the detection devices that I have on the aircraft, they give me potential distances from, so I have radar or LiDAR or other device like that, and I can see around the device, even if it's cloudy, even if there are obstacles, even if there are things that don't give line of sight direct with the potential other aircrafts. So this is the IFR. And then the new introduction, one of the new introduction of that we discovered doing this research is the AFR, that is the autonomous flight rule. In this case, this is delegated completely to the device itself. So it's the device, I mean the vehicle that is able, according to the instrument that is on board, according to the communication devices that are on board, and the control that the device itself is able to produce on itself, to define what to do and how to avoid the other aircraft that can create a potential collision. So these are the methods of separation based on rules, so specific rules and protocol to follow, but there are even others that are more based on model, especially statistical stochastic model that says, for example, in this area, the weather condition is 90% of the time very windy, and this created in the past a lot of problem with wind impact on the aircraft itself. So we want to avoid this area, and what we do is through probabilistic model we define the best separation from these areas in order not to cross them, and so geofencing, as we say, this area so that it cannot be entered somehow. The last one is by using simulation. Using all this data, actually we can determine let's say the behavior that the aircraft might have. We can transport this in a digital twin, and we can study it in simulation before really flying. These, of course, are all tools that are very useful also for the regulatory agency that have to be able to predict what to do in each situation. So just to conclude, the research that we have done, besides defining what is there, it also gave us the possibility to understand what is missing and what we should aim at for the research and innovation part in order to get to advanced aerial mobility complete framework. So first of all, integrated frameworks with all the elements that we have mentioned actually don't exist in literature. So there is nothing that takes into consideration all the aspects that we have mentioned. The second is that the taxonomies that have been produced till now for defining corridor and separation of corridors is not sufficient. So there are only few elements investigated into them, and this needs much more research. Demand and capacity have not been completely assessed in the sense that there are studies on the demand or on the capacity, but not much on the balancing, and especially how to create a dynamic balance between demand and capacity if this changes in time. And the last one is that this field, of course, comes from the legacy aviation, that is the old aircraft systems, whereas we are moving towards autonomous vehicles, and in this case, we need to consider this as a different aspect, as a different topic. Potential trends is the fact that, as you know, data is the new oil of this millennia. So having data, we can foresee many of the scenarios and many of the potential hindrances that we will have in defining air corridors. So one trend is to use real-world data in order to get towards this integrated model. The definition of security is not enough at the moment, and this is another trend, as, for example, the cybersecurity in order to avoid GPS spoofing or jamming or other kind of problems that might arise during a flight. Then how to price the flight itself. This is still something that is not defined and is studied more and more, how to define a good price that is good for the people, but at the same time offers some revenue to the company. And in the end, the sustainability, so in the sense of how the environment is impacted by flying with smaller or bigger devices, and how this can be somehow coped by the environment itself. Thank you very much. This is my